wants to talk a little more about complex numbers? I know, exciting, right? So first of all, we just talked about how I is that imaginary unit, and that is the square root of -1, and that's called the imaginary unit. And we're going to use that when we're finding those real zeros. But we keep saying complex, not just imaginary, and that is A plus BI. So this is the format of a complex number. A and B are just real numbers. Of course, I is that imaginary unit. Okay, so for example, complex numbers, you could have 1 plus 3i. You could have 2 minus I. You could have 9i. Okay, you don't have to have, if you don't have a number for A, of course, that would be 0, right? So A would just be 0, and there's just the imaginary portion of the number. Technically, if you had the number 6, you could call that a complex number because B would just be 0. So the imaginary portion is the 0. Okay, so these are all really complex numbers. They're just not all written in the complex form. The normal thing we're going to see are these first two, and even this third one I think we saw in the last problem. So what we want to notice, though, when we're solving these problems is a rule called the conjugate pairs. Okay, sounds kind of creepy, interesting, right? Conjugate pairs. So all complex numbers come in pairs. And in other words, if you have A plus BI as a solution, you will also have A minus BI as a solution. Okay, so for example, if you have 1 plus 3i is an answer, you will also have 1 minus 3i. If you have 2 minus i as a solution, you know 2 plus i is also a solution. Same for 9i. If you have 9i as a solution, then negative 9i is also a solution. The 6, that doesn't really have a conjugate pair because it's 6 plus 0i. So 6 minus 0i is also 6. Right? So that's why those don't have a conjugate pair with them. We are going to see this in all of the complex factoring that we do. Anytime we get one complex factor, we're also getting the other complex factor.